Hi, I welcome you for this session on sigma delta converter. It is a type of A to D converter. We know what this converters it comes under the course linear integrated circuit. To know the operation of sigma delta converter, first we should have a knowledge on the concepts of oversampling and noise shaping. First we will get into that, then we'll see the principle of operation of sigma delta converter in detail. The concept of oversampling I discussed here by considering that the sampling concepts you know it already. Oversampling. Oversampling it implies that sampling at a rate greater than the Nyquist rate. Here see 50 60 Hz signal it is shown. This signal it is sampled at a rate of 5 times that of the Nyquist rate, and the second signal which is shown in blue is the one which is sampled at a rate of 64 times of that of the Nyquist rate. These samples are very closely spaced compared to the one which is shown in red. Right? Now, why we are doing this oversampling? What is the advantage of this? Can you guess? Okay, we will see that. Now, oversampling advantages. First, it reduces the need of anti-aliasing filter, and the second thing, the quantization noise within the frequency of interest also gets reduced. How this happens? This is clearly shown in next slide. First graph shows the frequency spectrum under normal sampling condition. Here, if you see this, there is an overlapping area between the higher end of the baseband signal and the LSB of the sampled spectrum. This overlapping effect is said to be as aliasing. Whereas this effect will not be there if we do oversampling operation. That is, this is shown in the second graph here. That is, we had did the oversampling. Because of this, the sampling it is done at a rate greater than the Nyquist rate. That is, it is very much greater than the maximum frequency. So the sampled spectrum it is shifted away so long from the maximum frequency. So there is no overlapping between this two sideband frequencies. So aliasing effect is overcome. This is one advantage. Next, what happened to the noise effect in this oversampling process? Generally, quantization noise, if it speaks, it's spread out uniformly for all frequencies. And if you see this graph, quantization noise is more or less uniformly flat and the signal amplitude is very high. By oversampling, the average value of quantization noise is still reduced and the signal amplitude is high compared with the noise amplitude. Quantization noise outside this frequency of interest can be removed by normal filtering operation, but there is still a noise in the frequency of our interest. To remove this noise, we are doing noise shaping. This is done by using a noise shaping filter, and this filter it pushes the quantization noise out of the frequency of interest. Right? Okay. With this knowledge, now we will see the principle of operation of sigma delta converter. Sigma delta converter it is a high resolution, low cost A to D converter, and this integrates both the analog and digital circuitry. That is one more advantage. And here oversampling and noise shaping concepts are applied, and this in this converters we are using comparators and integrators. That is why it is said to be as delta sigma converter. This is the functional block diagram of sigma delta converter. Here if you see it, this first block it is a differential amplifier, second block is an integrator, third block it is comparator, and finally in the feedback loop we are having one bit D2A converter. First, the input signal whatever we are going to sample it is applied here, and from the feedback loop what is the data we have obtained, the two data are gets compared here, and that resultant comparison output difference in these two amplitudes it is given here as x2, and this x2 it is added up with the previously sampled value, and then it produces the new integrated output. Then that integrated output, it is compared here by using a comparator whose inverting input is ground at ground potential. So when the input is less than 0 volt, it produces one output, and when the input is greater than 0 volt, it produces another output. And once again see here, this comparator is a 1 bit A to D converter. So the output can be a 1 bit, either it can be 1 or it can be a 0. It is 1 if the difference is positive, and it is 0 if the difference is negative. And based on this, whether 1 or 0 is given, output of 1 bit D2A converter, it will become either plus 1 or minus 1 volt. And once again, this plus or minus 1 volt, it is taken as a feedback input and it is compared with the signal input. Once again, if any difference is there in this signal, that difference in data is taken, and that difference it is once again integrated, and this cycle continues until we get a required output. Right? This is the description about the block diagram. Now we will see that how this block operates by using this flow chart. We have taken input as x1, output of differential amplifier as x2, and the output of integrator as x3, and the output of A to D it is x4, output of D to A it is x5. So the difference between the input and the sampled feedback output, it is given as x2, and the output of differential amplifier x2, it is added with the previously integrated value and it is taken as a new integrated output. If the integrated output is greater than 0, x4 is taken as 1. If the integrated output is less than 0, x4 is considered as 0. And based on it, x4 whether it is 1 or 0, x5 is taken as either as plus 1 or as minus 1, and once again this loop gets executed and we will get a feedback pattern, and this process continues until we get a desired results. And this concept, it is shown here clearly with this example data. Here consider that x2 is initially 0, x3 is initially 0, x4 is 1 and x5 is 1. Now, if input x1 is 0.5, what happens to x2? X2, it is x1 minus x5, so it becomes minus 0.5. And x3, which is x3 minus x3 of n minus 1 and plus x2, it will become minus 0.5. And x4, it is nothing but either 1 or 0 based on x3 whether it is positive or negative. Here it is negative, so output is 0. If it is 0, then output of D2A will be minus 1. Right? Now this process continues like this and till we get a final solution. Okay. Here if you see this, density of 1 is more when the input is more positive, and the density of zeros is more when the input is more negative. That is here, which is shown in this slide. Right? So I think now you have understood the concept of A to D converter by using this sigma delta conversion very well. Right? And this is the simulation result for it. This is a sinusoidal input and this is a D2A converter, and this is the final sigma delta input output what we have obtained. Thank you.